It says, given the information marked on the figures, classify each quadrilateral as a parallelogram or not necessarily a parallelogram. Note each figure is drawn like a parallelogram, but we should not rely on the shape of the figure to determine our answers. We need to rely on the markings. So we're trying to determine whether or not these are parallelograms. First off, let's review what creates parallelograms. There are 5 scenarios in which you have a parallelogram. If you have opposite sides which are equal, then it's forced to be a parallelogram. If you have opposite sides which are parallel, notice little arrow feathers, then it's a parallelogram. If you have a scenario where opposite angles are congruent, again, that's opposite angles are congruent, then it's a parallelogram. If you have a scenario where consecutive angles, that means angles right next to each other, are supplementary or add up to 180, then it's a parallelogram. And the last circumstance is if the diagonals bisect each other, cut in half. In other words, it's the midpoint going both ways, then it's a parallelogram. So these are the 5 circumstances of a parallelogram. Let's take a look at the first one. Notice here, it's these 2 angles are equal, which that makes this an isosceles triangle, which makes these 2 sides congruent, and these 2 angles are equal, which forces this to be an isosceles triangle, but not necessarily congruent to the other side. So here, opposite sides are not equal. It's consecutive sides. So this could be a kite. So this is not necessarily a parallelogram. Notice here, again, the fact that we have consecutive sides which are congruent, not opposite sides. So it could be a kite. Let me draw that so you can see that, because a kite means consecutive sides are congruent, but not necessarily opposite sides are congruent. So there we have a kite. So given this circumstance, this is also not necessarily a parallelogram. In this one, we are given the fact that 2 angles here are equal and 2 angles here are equal, but these are consecutive angles which are congruent. So that is not forced because we must have opposite angles. This could technically be a trapezoid. Let me draw this, an isosceles trapezoid. If you have 2 legs equal, that would force 2 consecutive angles to be congruent and these upper angles to be congruent. So this third one, again, not necessarily a parallelogram. Let's look and see what we have here. We have 1 set of parallel sides. Good, that's the start of this. And then these angles right here are equal, which means we have alternate interior angles which are congruent, which would force these 2 sides to also be parallel. I call those armpits of the Z because they are the armpits of a Z. So we have opposite sides which are parallel. So finally, our last one is a parallelogram. So the first one is not necessarily a parallelogram. This one, not necessarily a parallelogram. This one, not necessarily a parallelogram. This is the only one that is forced to be a parallelogram.